In this video, I'm going to solve question number 1 from the new Syllabus Mathematics Book 1, updated 7th edition. Chapter number 1, Primes, Highest Common Factors and Lowest Common Multiples. Exercise 1A, question number 1. Determine whether each of the following is a prime or a composite number and find their all possible factors. First part from this question is 67. To solve this question, we first need to determine whether the given number is prime or composite. A prime number has only two factors, 1 and the number itself. In the case of 67, it has only two factors, 1 and 67. Because 67 is divisible only by 1 and the number itself, that is 67, therefore 67 is a prime number. Now let's define the factors. Factors of a number are defined as numbers that divide the original number exactly, that is, with zero remainder. For example, 2 is a factor of 4 because it divides 4 exactly, that is, with zero remainder. Now as for the factors of 67, we have identified that 67 is a prime number. So 67 has only two factors, 1 and 67 itself. Remember, 1 is a factor of every number. In the second part, we have to determine whether 87 is a prime or composite number. Since 87 is divisible by 1, 3, 29 and 87 itself, it has more than two factors. Therefore, 87 is a composite number. The possible factors of 87 are 1, 3, 29 and 87. Switching to number 3, we have 73, which is again a prime number. Only 1 and 73 can divide the number 73. Other than that, no number can divide 73. Therefore, 73 is a prime number. And the possible factors for 73 are 1 and 73. In the fourth part of the question, we have 91, which is a composite number. The factors of 91 are 1, 7, 13 and 91. So 91 has more than two factors and is therefore a composite number. The possible factors of 91 are 1, 7, 13 and 91. Question number 2. Find the first 5 multiples of the following numbers. Now before solving this question, let me explain multiples. A multiple of a number is the product of the number and some other number. For example, when we multiply 3 by 5, we get 15. That is, 3 times 5 is 15. Here, 15 is the multiple of 3 and 5. To find the first 5 multiples of 15, I'll multiply 15 by 1, 2, 3, 4 and 5. So 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45, 15 times 4, 60 and 15 times 5, 75. So these are the first 5 multiples of number 5. Second part from this question is 28. To find the first 5 multiples of 28, I'll multiply 28 by 1, 2, 3, 4 and 5. 28 times 1, 28, 28 times 2, 56, 28 times 3, 84, 28 times 4, 112 and 28 times 5, 140. Third part from this question. So these are the first 5 multiples of 53. 53 times 1, 53, 53 times 2, 106, 53 times 3, 159, 53 times 4, 212, and 53 times 5, 265. These are the first 5 multiples of 60. 60 times 1, 60, 60 times 2, 120, 60 times 3, 180, 60 times 4, 240, 60 times 5, 300. To find the first 5 multiples of 33, let's multiply 33 by 1, 2, 3, 4 and 5. So 33 times 1, 33, 33 times 2, 66, 33 times 3, 99, 33 times 4, 132, 33 times 5, 165. Last part from this question is 41. So let's find first 5 multiples of 41. 41 times 1 is 41, 41 times 2 is 82, 41 times 3 is 123, 41 times 4 is 164, 41 times 5 is 205. Question number 3. Find the prime factorization of each of the following numbers, leaving your answer in index notation. Now I have defined the terms prime numbers and factors in the solution to question number 1. In this question, I will demonstrate how to factorize the given number 72. The process of factorizing 72 begins with the smallest prime factor, which is 2. Dividing 72 by 2 gives us 36. Continuing with the smallest factor, we divide 36 by 2 to get 18. Dividing 18 by 2 results in 9. Since 9 is divisible by 3, we divide it by 3 to get 3. Finally, 3 is divisible by 3, which gives us 1. This process of division continues until we reach 1. Now the prime factors of 72 are 2 times 2 times 2 times 3 times 3. In index notation, this can be written as 2 raised to the power 3 times 3 raised to the power 2. The second part of the question is 187. 187 is an odd number. So 187 is not divisible by 2. Since the sum of the digits of 187 is 1 plus 8 plus 7 equals 16, which is not divisible by 3. The last digit of 187 is neither 0 nor 5. So 187 is not divisible by 5. To test whether 187 is divisible by prime numbers more than 5, it is advisable to use a calculator. Let's start with the smallest prime factor 11 to divide 187. I'll divide 187 by 11 to get 17. And then divide 17 by 17 to get 1. Now the prime factors of 187 are 11 times 17. The third part of this question is 336. Since 336 is an even number, it is divisible by 2. If I divide 336 by 2, we get 168, which is another even number. Dividing 168 by 2 gives us 84, another even number divisible by 2. If I divide 84 by 2, we get 42. Dividing 42 by 2 gives us 21. 21 is divisible by 3, so 3 times 7 is 21. In the end, 7 times 1 is 7. Now the prime factors of 336 are 2 times 2 times 2 times 2 times 3 times 7. In index notation, this can be written as 2 raised to the power 4 times 3 times 7. The fourth part of this question is 633. Since 630 is an even number, it is divisible by 2. If I divide 630 by 2, we get 315. Since the sum of the digits of 315 is 3 plus 1 plus 5 equals 9, which is a multiple of 3. So I'm going to divide the number 315 by 3 to get 105. Again, if I divide 105 by 3, we get 35. Now I will divide 35 by 5 to get 7. And at the end, 7 is a prime number itself, so 7 times 1 is 7. Now the prime factors of 630 are 2 times 3 times 3 times 5 times 7. In index notation, this can be written as 2 times 3 raised to the power 2 times 5 times 7.